This is Mrs. Wainwright's Math Class, Chapter 4, Lessons 6, 7, and 8. Multiply a decimal number by a decimal number. Meet beautiful Betty. The learning targets by the end of today's lesson, you should confidently be able to say, I can multiply a decimal number by a decimal number, and I can properly place the decimal in the final product. And to review the last lesson, why is the correct placement of the decimal important? Because it changes the value of the number. And there is a difference between the value of 34 chocolate bars, 3 4/10 chocolate bars, and 0 34/100 of a chocolate bar. Looking at the whole numbers alone, 34 chocolate bars is 34 whole bars. 3 4/10 of a chocolate bar is only 3 whole bars with 4 tiny little tenth pieces. And 0 34/100 of a chocolate bar is 0 whole chocolate bars and 34 tiny little pieces of hundredths. And there is a difference between the value of $15, $1.50, and $0.15. Even though they all have a 1 and a 5, they have very different values. In the real world, most multiplication problems involve money, weight, and measurement, all of which usually include decimals. So it is very important to know how to correctly place a decimal in a product. And remember, add, subtract decimals means always straight decimals. We line them up in the problem, and they're in the same spot in the answer. But multiply, divide decimals means must dance decimals. So for this lesson today, we are back at the dance club, and so today we have Decimal Dan in the house. And we also have beautiful Betty. Decimal Dan, we know he's the dancing man, and he likes to dance like crazy, but with all that dancing, he gets thirsty, and he needs to go to the fruit punch bowl. Beautiful Betty is in love with Decimal Dan. She thinks he's so dreamy, and she wants to be his girlfriend. So when Betty sees Dan go to the fruit punch bowl, Betty follows him, so she can talk to him at the fruit punch bowl table and flirt with him. She's hoping that Dan will ask her to dance with him and they can dance together as a couple. Let's see what happens. So they're dancing away, and as usual, Dan gets thirsty. He's going to go to the fruit punch bowl. How many people does he have to walk around? He's going to walk around one person to get to the fruit punch bowl. So I'm going to write a 1 over him. Here's Betty. She sees Dan at that fruit punch table, and she wants to go flirt. So how many people is Betty going to have to move around? She's going to have to dance around 1, 2 people to get to that fruit punch bowl and to be able to talk and flirt with Dan. So we'll write a number 2 on top of Betty. Now, while they're at that fruit punch bowl, the 5th graders will have a multiplication problem with numbers, factors that have no decimals in them. We know how to solve that. And while we're solving that, Betty is going to flirt and bat her eyelashes at Dan. And she hopes that Dan will ask her to dance. And guess what? By the time we're multiplying, it's worked. Dan says, Betty, would you like to dance with me? And of course, Betty is so happy and says yes. So what do we have to do? They are now no longer 2 separate people. They are a couple. So we're going to add their steps together. And 2 plus 1 equals 3. So we'll put their total number of steps, since they are a total couple, into a heart. And then they will dance back together into the product, the answer to the multiplication problem, as a total couple, a total of 3 steps. Let's see how it works. So example number 1 is 2 39/100 times 2 7/10. So anytime I have a multiplication problem, I'm going to write it vertically. I'm going to put the number with the most digits on top. So that's 2.39 times 2.7. Remember, this is multiplication, and add and subtract, you have to line up your decimals, but multiplication and division, you do not. You can just write your numbers down. So my first decimal that I see is always going to be Decimal Dan. There he is. We're going to move him out to the fruit punch bowl. 1, 2 steps. So he moves out 2 steps. We'll write it down and circle it. But underneath him, I see beautiful Betty, and we know she's going to follow him because she wants to flirt. Betty's going to move out 1 step to get to the fruit punch bowl. Now we 5th graders are ready to multiply. But while we are multiplying, Betty's plan works, and Dan asks if she wants to dance with him. So now they have become the total couple. We'll add them together to find their total. 2 plus 1 equals 3, and since they're the lovebirds, we'll put their total couple number into a heart. So what does it mean that I have as a math problem? Since I've danced them both out, I have 239 times 27 because we've removed the decimals from the problem. Well, we know how to solve a problem like this, so let's move to scrap paper and solve this problem the way we like best. So maybe you're a traditional method fan, and if so, this is how you'd solve it. You'd say 239 times 27. You're going to multiply by the digit in the ones column first, which is the 7. So you'll say 7 times 9 is 63, put down the 3, carry the 6. And 7 times 3 is 21, plus 6 is 27, put down the 7, carry the 2. And 7 times 2 is 14, plus 2 is 16, put down the 6 and the 1. We've now used the entire 7, so we cross it out and everything that we carried. We're moving on to the 2, which is in the tens column. And since it's in the tens column, we put a 0 to show that we're multiplying by a digit in the tens column. Now we say 2 times 9 is 18, put down the 8, carry the 1. We say 2 times 3 is 6, plus 1 is 7. And we say 2 times 2 is 4. We add these numbers together. 3 plus 0 is 3. 7 plus 8 is 15. Put down the 5, carry the 1. 1 plus 6 is 7, plus 7 is 14. Put down the 4, carry the 1. 1 plus 1 is 2, plus 4 is 6. But we're not done, because remember, we danced Dan and Betty out. They're now the total couple. They're going to dance back in as a couple. So we take that number in the heart 3, we bring it down, and we're going to dance it into our product 3 places. 1, 2, 3. And this is where our decimal would fall. Maybe the traditional method isn't for you. Maybe you're a box method fan. So if that's the case, we draw our box. 239 is 3 digits, so we'll separate our box into 3 sections. 200, 30, and 9. 27 is 2 digits, so we'll separate that side into 2 sections, 20 and 7. We're getting ready to multiply. First we put in our place value zeros, and then basic facts 2 times 2 is 4. Put in our place value zeros, basic facts 3 times 2 is 6. Put in our place value 0, and 9 times 2 is 18. Put in our place value zeros, and 2 times 7 is 14. Put in our place value zeros, and 3 times 7 is 21. There are no place value zeros, so 9 times 7 is 63. So we're going to add these up and then add them together. We add, and we get 4,780. Add this side, and we get 1,673. So now we will line them up and add them together to find our total of 6,453. But again, we danced the decimals out, so we need to dance that happy couple back in their total, which is 3 places. 1, 2, 3. And the decimal goes right there. So no matter which way you chose, traditional or box method, your product would be 6 and 453 thousandths. So let's go back and put that into our original problem. 6 and 453 thousandths. Please stop the video and complete worksheet number 1. Let's take a look at example number 2. Jonathan and Joe have pet slugs. They decide to have a slug race. Jonathan's slug moved 0 and 2/10 of a foot. Joe's slug moved 0 and 6/10 times as far. How far did Joe's slug travel? Ugh, this is kind of gross, but cool at the same time. A pet slug? I wonder what that would be like. Well, it's a word problem, so let's go back and find our question. How far did Joe's slug travel? What do we know? We know that Jonathan's slug moved 0 and 2/10 of a foot. And we know that Joe's slug moved 0 and 6/10 times as far. Well, times right there tells me what I need to do, right? I'm going to need to multiply. When I multiply, I put the number with the most digits on top, and these numbers both have 2 digits, so it doesn't make a difference. Therefore, I'm going to write 0.2 times 0.6. And I am ready to multiply, but I see some decimals. And when I see decimals, I know so I'm going to have to move my decimals. And my first decimal is Decimal Dan. How many places does he have to move to get to the fruit punch table? 1. Write his number and circle it. There's Betty. She's going to follow him. How many places does Betty have to move to get to the fruit punch table? 1 in this problem. Write it and circle it. And while the 5th graders multiply without decimals, Betty will flirt with Dan and hope to become a couple. And Betty's trick works. Dan asks if she'll dance with him. So we add them together to make them the total couple. 1 plus 1 equals 2. Let's put them in a heart since they're in the total in love couple. So now we're ready to multiply. So we're going to say 2 times 6 is 12. Put down the 2, carry the 1. We're going to say 6 times 0 is 0, plus 1 is 1. I don't need to multiply everything by the 0, which is my next digit on the bottom factor, because anything times 0 is going to be 0. So I can stop there. But I'm not done. My answer is not 12 because remember, I have to dance the happy couple back in. Their total is 2, so the total steps they dance back in together as a couple will be 2. 1 place, 2 places, and put the decimal there. So the question said, how far did Joe's slug travel? Joe's slug traveled, well, I can't start a number with a decimal. I know Mrs. Wainwright won't be happy with that. So I know I'll put a place value 0 before it. 0 and 12/100ths foot. Why is that foot and not feet? Because my whole number is 0. Feet would be plural, which means there's more than 1. And I have less than 1. So it would be 0 and 1/12 of a foot. Please stop and complete worksheet number 2. Example number 3 says a huge Hershey bar costs $24.75. Brooke is going to split it with her friends. Brooke needs to pay for 0 and 3/10 of the Hershey bar. How much does Brooke need to pay? Well, I have a word problem, so I'm going to underline my question and see what it's asking. I need to know how much does Brooke need to pay. What do I know? I know that the Hershey bar costs $24.75. And I also know that Brooke needs to pay for 0 and 3/10 of it. And I do remember from chapter 1 that anytime I have a fraction or a decimal and I see the word of means times or multiplication. So I'm going to need to multiply $24.75 times 0 and 3/10. Well, $24.75 definitely has more digits, so that's what I'll write on top. Underneath that, I'll multiply it by 0 and 3/10. Remember, this is multiplication. Multiply, divide decimals must dance decimals, so they do not, nor should they be lined up. Okay, we're ready to multiply, but I see decimals. And when I see decimals, I know that means so Decimal Dan is going to dance out to get his drink of fruit punch. How many places does Dan need to dance out? Let's see. 1, 2 steps. Write down his steps and circle it. Betty's going to follow so she can flirt. The Betty dances out 1 step, write down her step, and circle it. While the 5th graders multiply without decimals, they talk, chit-chat, and Betty's plan works. Dan asks her to dance. They become the total couple. Let's find their total. 2 plus 1 equals 3, and we'll put it in a heart for the total couple. Now we're going to go ahead and multiply. So we're going to say 3 times 5 is 15, put down the 5, carry the 1. And 3 times 7 is 21, plus 1 is 22. Put down the 2, carry the 2. And 3 times 4 is 12, plus 2 is 14. Put down the 4, carry the 1. And 3 times 2 is 6, plus 1 is 7. But I'm not done, because I have to dance the happy couple back in their total number of steps. Their heart reminds me that their total number of steps was 3. Don't forget to put a dollar sign since it's money, and let's dance them in 1, 2, 3 steps. Put the decimal right there. So the question says, how much money does Brooke need to pay? Well, what's my answer? $7, decimal 4, 2, 5. Oh, that doesn't seem right. I never have money with 3 digits in a decimal place, because we don't in the United States have coins that are less than 1 cent. Well, when this happens, you must round it to make it into money. So what I'm going to do is I'm going to underline the penny column, because I don't want anything smaller than a penny, and I will underline everything to the left. Now remember, when we round, on the left side, the entire underlined number gets written. So it's going to be a $7, decimal 4, 2. And on the right side, we add 1 to the very last digit. So we're going to add a 1 to this 2, which would give me $7, decimal 4, 3. I circle the first digit that's not underlined, which is the 5, and that tells me whether I'll round up or down. Well, 5 is in a little kid's school or a big kid's school? Oh, we know for sure it's in a big kid's school. So that means this number is going to round to $7.43. So although it doesn't say about or tell you to estimate or round, you cannot give a money answer that has more than 2 places in the decimal column. So if you have more than 2, you are required to round it to the nearest cent or the nearest penny. So my final answer would be Brooke needs to pay $7.43. And that's the answer to problem number 3. Please stop and complete worksheet number 3 right now. So let's review. Why is the correct placement of the decimal important? Because it changes the value of the number. There is a difference between the value of 34 chocolate bars, 3 4/10 chocolate bars, or 0 3/400 chocolate bars. There is a difference between $15, $1.50, and 15 cents. Remember, in the real world, most multiplication problems involve money, weight, and measurement, all of which include decimals, so it is very important to correctly place the decimal in a product. Remember, add, subtract decimals is always straight decimals, but multiply, divide decimals is must dance decimals. They do not need to be straight, nor should they be straight. We simply dance them out and dance them back in. Remember, when Dan is on the dance floor, he's going to get thirsty and walk around people or digits to get to the fruit punch bowl. And if Betty is there, she is going to bat those eyelashes and follow him out, walk around people herself, so that she can flirt with him while the 5th graders multiply. That always works for her. They become the total couple, so we find their total, and we dance them back in their total number. So in this problem, Dan danced out 2 places, Betty danced out 1 place, giving them a total of 3 places. And in that final answer, we danced that total couple back in 3 places. In problem number 2, Dan danced out 1 place, Betty danced out 1 place. As a total couple, they were 2 places. Therefore, they danced back into the problem 2 places. And finally, in example number 3, Dan danced out 2 places, Betty danced out 1 place. They became a total couple, which gave them a total of 3 places, and they danced those 3 places back into the problem. So hopefully by now you can confidently say, I can multiply a decimal number by a decimal number, and I can properly place the decimal in the final product. Remember, we'll be doing more practice in class, and if you still have difficulty, please see a teacher so that we can help you. Good luck with the lesson.